Welcome back to Algebra 2. Let's take a look at the equation that is log base answer equals exponent and use that to convert these back and forth in order to be able to solve. This is something that you did in Algebra 1. So when you rewrite these things, this is how it should be rewritten. Log base, the answer goes here, equals this. Then I can rearrange that equation. To solve for x, that is something that we can number crunch. When we rewrite the second one, the opposite of e is ln to the exponent equals the answer, and then solving that for x, we would get this equation. This is going to be log base 3 of 4 equals the exponent, and simplifying that we get this. Since this is log, we're now going to go the other way. So the base 2 to the power -1 becomes the answer. 2 to the -1, we can actually do that. We know it's 1/2, and that's how we can solve by subtracting 5 or 10 halves. This is a log base 10, so it's going to be 10 squared. 10 squared is 100. That's why we can solve this. ln, the opposite is e to the 1/3 power, and e to the 1/3 power, we're just going to simplify this way. We'll do more of these. So there are two ways that we're going to look at solving exponents. The first one is to convert it to a logarithm using the equation log base answer equals exponent. The second method we use when the base is identical. So down here we have b to the x and b to the y. Well, b is the same in both of these. B does have to be a positive real number for this to work. It doesn't work for negatives. So if I have 3 to the x equals 3 to the 5th power, then x has to equal 5. The exponent equals the exponent. And the equation is back to Algebra 1 again. We'll see some examples of this. So here we are going to convert these to logs, and when I convert this to a log, log base 2 of the answer equals the exponent. And how do I do that? Last time we could convert these, so we can do log of 5 on the top and log of 2. That converts it to a common log, and that allows us to grab a calculator to do those. So when we number crunch those two things in a calculator, we're going to get 0.6989. These are kind of like trig. Take quite a few decimals because they're kind of ugly things. And if you take a bunch of extra decimals, then when you do the division, you should not be having rounding error. So we have 2.3 as the final answer. So again, we're going to convert this to a log. The log is going to be base 7 of 15 equals 9x. So we can actually do this as a conversion, log of 15. That's common log of 15 divided by common log of 7. I would prefer to do this before I move the 9 over. Just simplify this part of it first. So we currently have 1.176 divided by 0.845. That's going to give us 1.39. Don't see my decimal. That is now equal to 9x. So how do I get rid of the 9? I'm going to divide by 9. So I get 0.15. Okay, on this one, I don't have everything with the exponent by itself first. So the first thing I need to do is I'm going to move things around. So I'm going to add 7. That's going to give me a 20. I also am going to move that 4. So that means I'm going to divide by 4. Remember, common technique. We move everything away from the thing that we're trying to deal with. The thing we're trying to deal with is our E. So now we're ready to take ln 5 equals negative 0.3x. So in this case, we can actually just grab a calculator for ln of 5, and then we're going to end up dividing that by negative 0.3. Make sure when you do that, the calculator is going to give you parentheses. You gotta close them. For an answer of negative 5.4. Okay, these are ones that have the exact same base. So this is the second method. What I notice, no matter what the base is, I'm going to take the exponents. I'm going to say exponent equals exponent. Hey, we're back to algebra 1 again. We're going to add 1 to both sides. And x here is 6. Exponent equals exponent. Moving things around, if I subtract the 4x, simply because the x is already on the other side by itself, I'm going to get negative x equals negative 5 dividing by negative 1, x equals positive 5. And on my last one, e, now I can have a power taken to a power. What that does, if we remember, is multiply. So I'm going to use distributive property. I have 2x minus 8, subtracting 2x from both sides. So I have negative 8 equals x. Now they're not always this easy. So what we can have is the base is not the same, but it's related. And it's related because we know that 125 is 5 cubed. So what we do is we replace this, goes in for the 125. So we're going to have 5 to the third, then taken to the 2x. Oh, that means I'm going to multiply the exponents. And 5 to the 3x minus 2. So take the exponent, 3x minus 2 equals 3 times 2x. So that's going to simplify to 6. I'm going to subtract 3x from both sides. 3 times 2 is 6, minus 3 is 3x, and dividing both sides by 3. And you are not allowed to write that any other way but a fraction. Negative 2/3. So let's take a look at another couple examples that are like this. I have 4 as a base and 1/2 to a base. What I'm going to do is convert both of those to 2 to what power? 2 squared is 4. 2 to what power will give us 1/2? It is in the denominator. That means I need to make that power a negative. So this is going to be 2 to the negative 1. Now here the parentheses go on this first part, but when I take the powers, 2 multiplied by whatever the second one is, notice how the parentheses moved. It's kind of important. Hopefully you're not going to hear that. My washing machine is getting rattly. Okay, so now we have 4 equals, distributing this, I'm going to get negative x plus 3. So I'm going to move the 3. That's going to give me 1 equals negative x, dividing by 1, negative 1 equals x. Okay, 3 and 9, how are they related? 9 is 3 squared. So when I originally write it, I'm going to have 3 squared inside parentheses, but then when I take the exponent, I'm going to swap the parentheses onto the other part, because if it does have a plus or a minus, I do need to distribute correctly. So this becomes 2 times 2x, so that's going to be 4x. Since I have the 7 over here, I'm going to move the 7x. Yeah, we'll deal with the negative signs. 2 times 2 is 4, minus 7 is negative 3x. And over here we simplify to negative 3. Dividing by negative 3, x is 1. Couple more problems like that. The problems that are probably a little bit more difficult are the ones where both sides would need to be changed. So both of these are powers of 10. So 100 is the same as 10 squared, and 1 over 10 is the same as 10 to the negative 1 power. So both of those are what I'm going to change into here. So I have 10 squared, ugly squared. Squared taken to the power x, and 10 to the negative 1. And remember right now that x minus 3 doesn't have parentheses, but when I take them out, I'm going to swap the parentheses onto the part that may be more than one term, and that means I need to distribute. This is going to give me negative x plus 3 and 2x. So I'm going to add x to both sides. 3x equals 3, dividing by 3, x equals 1. And here, the one that I need to figure out the power is 7 to what power gets me 1 over 49. It is in the denominator, that makes it negative. It's 49, that makes it 2. So this one gets replaced with negative x plus 5 power, the bases are the same, 3x, and I should give it more room, shouldn't I? Negative 2, and this part is in parentheses. Because I'm going to distribute that, that's going to become 2x minus 5. Subtracting 2x from both sides, and x equals negative 5. Okay, today's assignment is going to focus on exponents. Tomorrow's assignment will focus on logarithms with the same types of equations. Do not panic over a word problem. Substitute in what you know. When you take it off of the stove, the temperature, this is going to be TO, original temperature. The room temperature is TR, and my goal is to serve it at 100 degrees. That's my final T, and R is my rate. Everything's in here. I just need to plug them in. So, temperature I want the stew to be at. Initial temperature minus room temperature. You can simplify that. E to the negative rate T and plus the room temperature. Guys, that's now just a problem that you need to number crunch. So I'm going to move the 70 over to the other side, get 30. I'm also going to simplify what I have in here. So 142 e to the negative 0. I have one more thing that I'm going to move away from the base, and that's going to be, I'm going to divide by 142. And take several decimal places because .2113, 0.2113. Now that I have the exponent by itself, I'm going to convert it to logarithms. That logarithm is the natural logarithm of 0.2113, that's doable, equals negative 0.046 t. So let's grab a calculator for the natural log. That gives me negative 1.555. And that means I divide both sides by what is in front of the t. So it is going to take 33.8 probably minutes to cool to the temperature that we want to serve it at. Okay, substitute in, solve. You guys know how to do these. Your assignment is in the book. You're going to do some odd problems because I want you to check your answers. Make sure you're on the right track with those. We will have a homework help on Wednesday. Have a good day.